I want to walk you through some code for a single page application that uses all of the technologies that we've been discussing so far this term and introduces you to Vue and Vuetify. I'm going to start out in a super boring fashion by showing you how to launch this application. If you have not yet watched the video dealing with the full stack development and deployment environment, please go ahead and watch that before you continue with this video. This is a copy of my package.json file. You were used to seeing things like dependencies and dev dependencies and things in there, or the name of the project and so forth. But one of the things that's also included in these files is this scripts section. And this allows you to define scripts that can be executed at runtime from the command line. And there's two in particular. Actually, if you have watched that video about the development environment, the step where I said you had to run a separate processing step to combine your source files into bundles that can be served by the web server, that's actually this command right here, the build command, and it runs that Vue CLI service that was in the other video and gives it a build command to tell it to go ahead and assemble the source files into a bundle that can be deployed at production time. Another use for this Vue CLI service is called serve, and this is the mode that I illustrated in the video where the CLI service is keeping an eye on your source files and keeping your browser updated with the latest and greatest from your source tree when you run Vue CLI service with this serve option. So what I'm going to start out doing here is executing this Vue CLI service command, and you can abbreviate any kind of commands that you want to run from the command line by including them in this scripts object and then giving them an identifier that you want to use at the command line. So I'm going to switch over to my shell and just say yarn and then UI watch. I can see that yarn gives us a little prompt, and then it tells us that it's running the command that we asked it to, Vue CLI service, with the serve option. And it tells us it's starting the development server, and right now it just completed building the entire user interface application. And now that Vue CLI service is sitting out there waiting for a browser to connect to it to download the code. Remember that this happens differently in a development setting so that this Vue CLI service can remain aware of the changes that you make to your source code and then upload them again to the browser. So if I want to open this application on my browser, I get these URLs that tell me where the Vue CLI service is listening, and I can just select these directly from my shell, and then here's our single page application. So we're going to come back and show you how this thing works, but in order for this to work, I've also got to start up my happy server. So I'm going to switch back to my dev environment and show you that there's another command in here where in my scripts object I can invoke happyserver.js. Now happyserver.js is going to look quite familiar to you. I'm making a connection, I'm bringing in an objection, I've got some models that I'm setting up, I've got some routes that I've created and so forth. So this is kind of what the same sort of thing that you've been working on for a while now. But what I want to do is start this guy up. Now, it'd certainly be possible for me to just go out to the shell and type node happyserver.js. That would work totally fine. The downside of that is when I make changes to the source code in my happy server, Node doesn't notice that. It doesn't pay any attention to it in the same way that the Vue CLI service does, where it's going to automatically restart if I make changes to my source files. So there's this alternative to running Node directly. There's a program called Nodemon, which stands for Node Monitor. Kind of looks like Nodemon, but it's really Nodemon. And what Nodemon does is it keeps an eye on the file that you're running and any of the files that it is dependent upon. And if any of those things changes, it restarts the underlying program. So it does exactly the same kind of job that Vue CLI service does for the user interface, but for the backend server. So I'm going to go back to my shell and I'm going to fire up API. And I've called these guys UI watch, user interface watch, and API watch, because they both do the job of watching files for changing and restarting automatically. So I'm going to just create another shell in this same window. And then down here, I'm going to run yarn and then API watch. And you can see now that we get the output that we've all become familiar with, telling us that we're listening on this path, and here's our blip output that says what our routes are. We get a little bit more information here from Nodemon itself. It says, hey, I'm this version, and I'm watching these paths and looking for changes to these files. And then finally it says it's starting up happyserver.js, and notice that it's telling us that it's doing that with the node command. And then node goes ahead and runs. Now the neat thing is with either one of these, if I make a change to a file that it's keeping an eye on, and let me just go over here and I'm just going to make an innocuous change in happy server. So I'm going to just put another comment here that says hello. It doesn't really do anything, but it does change the file. Now watch what happens in this window when I save this out to disk. Hit the save command, and you notice that right away this guy woke up and restarted the program all over again. So now you can see there's sort of 2 runs of this, and that's just done automatically whenever you make changes to the source file. The same thing is true of the user interface. So if I go into the user interface source code and I bring up main.js and I just make a change and save it, now watch this window. You can see that it goes back and it rebuilds that application again. The cool thing though is that it only rebuilds what's necessary to accommodate the change that you just made over here in your source code. It took a lot less time to update itself with the change that I had made than it did to do the initial build, if you recall that. I'm going to get rid of this change, save again, file change, and it's going to update up here. And then I'm going to go back over to my happy server and undo this change, save, and you can see that happy server restarts again. So I've got 2 separate shells running 2 separate watch programs, one that's watching the user interface for changes and one that's watching the server for changes. It's also important to note that when I make changes to the user interface code, it's also going to update my browser with the latest and greatest content from my source file. So we're going to come back and look at this in more detail, but let me just show you this example where I'm going to make a change. So this right now says welcome single page app user. So I'm going to go back over here into my source code and I'm going to find that prompt. Here's my home page, and here's the source code for welcome single page app user. And I'm going to change that to say greetings. Now I'd like to make several things visible here. I want to bring the shell back up, and then I'm just going to scooch this out of the way. And I'm going to now save this file that I've now made a change to. And what we should see is that the Vue CLI service is going to update because I've made a change to my source. It's going to rebuild that portion of the application that changed, and it's also going to tell the web browser to update itself automatically. So all I'm going to do is type save. And you can see that this updated and then this updated with the same content that I've now put in my source code. So as you can tell, this is a super helpful way to do development. I'm going to go back here and undo that. And now as soon as I save, you'll see this change, and then the application will update back to what it was before. Save. This ran, and it updated the application. So although that sounds like a boring way to start this discussion, it's really quite cool functionality that you'll come to value as you're doing development in Vue and Happy. Okay, so let's go take a look at the application itself. It is very simple by design. It's basically just manages accounts and logins. So what I want to show here, first of all, let's run this sign up function. Now this is a little sign up page. I'm going to type in some values here. And then PASSWRD99. Now you notice that as I went through typing things, I was getting validation and prompts, and I get this kind of nice interface with the text edits and so forth. This is all courtesy of the Vuetify library that provides us with these user interface objects that's running inside of the Vue application framework. So I'm going to hit sign up, and I get a nice prompt that says we created an account called that same email address. I can hit OK, and now I'm back to my home page. Now, if I try to sign up again, let me do this with just put in the same information. And hit sign up. I get an error message. Sorry, the account with that email is already in use, right? So just a simple example of creating some very common sorts of screens that moderate the sign up process. So I'm not going to do that. Let me switch over here to, let me just show About Us. That just gives us some static content. But what I want to do now is sign in. So I get a pop-up here that lets me type in my email address and my super sophisticated password 99, and log in. Okay, I don't have much going on here on my main page, but you can see that up here in the menu bar, I now no longer have the sign in and the sign up button because I've now signed in, and I've got this drop down here that has my user, my first name in it, and it's got a sign out button, and it also has an accounts listing button. So if I hit accounts, I can see that I can get a little report here of some accounts that were already in the database, and then a new account that I just created, and this is highlighted to indicate that that's my my entry in the accounts list. And again, this is all, this table formatting and these icons and so forth are all provided courtesy of View plus Viewtify, showing these pieces of information, as is the menu bar, the footer, the drop down, the headers, and all that stuff. So now I'm going to finally sign out, and you can see that we change state and go back to where we're in a position where we can either sign up or sign in because there's no currently logged in user. So that's the little application that we're going to take a look at. Let's get to some familiar stuff out of the way here first. So I want to look at the server itself. This is all setup stuff that you're familiar with already, so we're not going to go into it in any detail. I'm using the blip library to show the list of routes, the Pino library to do logging, and then here's where my routes are being configured. So server.route, and then a list of the routes. So here's the first route we'll take a look at is this post route to accounts. This is obviously going to create a new account because it's a post request. Sign up for a new account. I've got some validation going on here with Joy. And then the interesting part is the handler itself. So it's an async function. It's going to do several things. First of all, I want to check to see if the account that I'm trying to create exists already, which is an error. So I'm going to do account.query and then check to see if the email column of the, or if there is an account whose email is the same as the request.payload.email. So again, because we're doing a post request, my payload has these fields that were picked up from the form that we filled out in order to create a new account. So if the request already exists, by merit of this being a non-null value, then I'm going to return a value that is going to be converted into a JSON object for transmit back to the client. Now, because I've got some intelligence over here on the client side, I can make good use of additional information that's being returned from the server. Now, I've mentioned in my earlier videos about Happy that sending the value back from your route handler is sometimes kind of up to you. How do you want to handle it? I've just established a really, really simple convention. You don't have to use this. It's not any kind of a standard. It's just what I've chosen to do in this app, where I'm always going to give back an object that has two fields at least, an OK field, which is just a Boolean. If the request was successful, it's going to be true. If it was a failure, it's going to be false. And then a message that I can use to display to the end user. And you can see here that this message, account with email, whatever the email was, is already in use. That was the message that pop-up box showed me in the user interface. So I'm using the information returned from the server to be able to display that kind of stuff. So if the account did not exist, then I'm going to skip down and I'm going to create it. So account.query.insert, and then here's the data that I'm trying to package in the database. And then I'm going to check to see, did this thing get created? If so, then I'm going to return a similarly formatted message, except I'm going to set the OK flag to true, and then give a message that indicates the account was created. If the new account didn't get created, then I'm going to return a false value again so that the server or the client side can display an error message and give some additional information about what happened on the server. So that's my create account endpoint. Here's a really simple one to get a list of existing accounts, right? So when I showed you that list of accounts that were already in the system, super simple, a get request to the accounts endpoint, and it's going to just do account.query. I should show you this account object. It's really simple. It's just extending the model class from objection and returning the account table. There's not even any relationships going on in here. I'll come back and talk about these things a little bit later. But that's all that's in the table. And then the account table itself is just an ID, first name, last name, email, and password, as you might expect from the other from the code and what we filled in those forms. I can delete an account, which I didn't illustrate before, but I can. So it's a delete endpoint, and it requires us to tell it which account ID do I want to delete. And then in the handler function, it does account.query, delete by ID. This is kind of a shortcut function that's defined in objection that avoids having to do an additional where clause when you already have an ID field, which is super common. So I'm just passing in request.params.id. So whatever ID was selected in here is going to be used to delete. And then I've chosen to handle the results directly inside of this promise. So I got a .then clause, and I'm checking to see if the rows deleted was 1 or not, because I expect to delete exactly 1 row here. And if so, I return one of these little status objects back to the client with a message that said, yeah, we deleted that account. Otherwise, if something went haywire, we say didn't work, couldn't delete that account. Here's the login endpoint. It's a post. Now, it seems a little weird in a way maybe that's a post request, but if you think about what a login is doing, it's actually changing some state on the server. And normally when you send a post request, or if really anything except a get request, you're going to be changing some state on the server. You're going to add something to the database that's going to change the state of the server. In this case, we're logging into the server, so it sort of makes sense that we're going to have some new state going on the server side to say, hey, this person's logged in, and so I'm using a post request to handle the login. It's not quite as clear-cut as an ordinary access to a resource like an account or a group of accounts, but in the same spirit of making the update to the state of the server. So the login route here, going to validate that I'm sending in an email and a password. So back here in the app, when I do this, the sign in, I'm asking the user for an email and a password, and that information is going to be sent to the server in a JSON object that contains those 2 fields. I verify them, then I'm going to go into my handler function. So I'm going to first of all check to see, well, does an account that has that email exist in my account table? If it does, then I'm going to do some more processing. Otherwise, I'm going to say, sorry, you gave me back a bogus email address or password. Notice that it's just a really common practice when you're verifying logins that you don't tell the user too much information. You don't want to say, sorry, that was a bad password, which sort of implies that the address was correct, which gives the bad guy some additional information that they wouldn't otherwise have. So you never really want to indicate what went haywire. Just say, hey, something went wrong here in one of these things you put in, and that doesn't give any information away to a bad guy. On the other hand, if we did find this account, well, then we're in this if statement. The account is going to be truthy. We also want to check to see if the password matches, and that's the job of this verify password function, which I'll come back and talk about in a minute. Now, if the password does verify successfully, then I'm going to return, again, one of these little return status objects. It's okay. I'm going to send back that I logged in successfully, and I'm going to send back some information that's going to be used on the client side to sort of keep track of who's currently logged in in the single page application on the client. And that takes care of the rest of the routes. The only thing here is starts up the server and then runs the init function like we've been seeing before. So should be quite familiar to you. With perhaps one exception is how do we deal with these passwords? Let's go back and look at the accounts, the account component itself, or the model class. So again, this is just extending the model class from objection, and we have to supply the name of the table in the database that's being used to store the information for this model class. And then we've got some additional information in this model class that's handling my password. Now, one way to store a password would be to just, the user types in, I typed in password 99 with a capital P. Now, it would certainly be possible for us to go out to our database and just store capital P password 99. And then when the user tries to log in the next time, we just take that plain text password and we compare it with a string comparison with what's in the database for that particular user account. A problem with that is that now we suddenly have a whole bunch of passwords that are visible to the naked eye. If somebody gains access to our system and finds the password file, we've basically given away the store. Every account on our system is now compromised, and those passwords are visible to somebody that wants to exploit the availability of those data without any protection at all. So what's usually done is that we're going to encrypt those passwords. Let me fire up another shell here. And I'm going to use this one, make the font a little bit bigger. I use this shell to talk to my database. So here's the pSQL client, and there's the name of my test database. And now I can ask for the names of the tables. I've only got one, really, is that account table, and then the other thing is the sequence that automatically increments when I insert new rows in the account. So if I say /d account, it'll give me some details about the account table. So as you can see from before, I've got an ID value that's auto incrementing, first name, last name, email, and password. So these are all just character fields. They have to be there. They're not null. And then there's a automatically created primary key index on the account ID you can see right here. So if I want to look at the contents of that, I can say select star from account. And it's a little bit big. You can see here, here's the account that I'd created before when I just logged in. Here's my name, my email address, and that's my password. Now this horrible thing is the encrypted version of capital P password 99. When I entered this account, it sent the password for my new account in plain text, which would be sent over an encrypted HTTP link if we were doing this in production, so that's okay. But on the server side, it encrypted that password and then stored the encrypted version in the database. That means that if a bad guy were to get a hold of our database, anything that was in here as an encrypted password would not be immediately accessible to them. They wouldn't just be able to say, oh, to log into this system, I use this email address and I use this password and I'm good. Because the password is very difficult to recover from this encrypted version. These other two here were just test accounts that I stuck into the database from some insert statements, so don't pay any attention to them. But the point here is that I've encrypted that password. Now when I want to log in, what I'm going to do is I'm going to get the email address and plain text password from the user over the secure HTTP connection. And then the server is going to do the same encryption step that it did to get this encrypted version of my initial password. And then it's going to take that value and compare it with what's in the database. And if those match, then the user supplied the appropriate password. So I don't have to store the actual plain text password. I just have to encrypt it the same way as I did when it was originally stored, and then verify that the encrypted values match up. So let's go see where that's happening in the source code. Here's the, let me go back to the server code. When we created our account, that was the post to the accounts endpoint. what we did was we just did an insert statement. So this just looks like ordinary objection code, right? Account model class, get the query object, insert the contents of the information that I got in from the client. So the magic isn't being done in here. It's actually taking place inside this account model. Turns out that objection allows you to define so this is our account class, and so far we've just seen the declaration of sort of static functions that return configuration information about the database. In this case, though, I've got this special function called $before_insert, and this is a special function in objection that says, hey, when you're about to insert something into this table, run this little function first and then insert it. So what before insert does is it takes the password, so this .password, that's the password that the user typed in, and it runs it through this hash function, and that's an asynchronous function, so we await it, and that's really the thing that does the encryption, right? It hashes the original password into this horrible, hard-to-guess string, and assigns that to the password in the current object. So the fact that this thing gets run automatically by objection before inserting something new means that that password is going to get encrypted prior to the thing actually being inserted into the database, which is how we end up with this crazy string inside the password field for that newly created account. There's another element here that is the thing that we use to check the password. So when it comes time for someone to log into the system and we look up their email address and we find a record that matches that email, we're then going to want to verify the password. So we take in the plain text password. This is what's just coming from the end user's user interface, and we pass that plain text password along with the encrypted password from before, and we run this compare function. So what the compare function does is encrypts this password the same way and compares it to this one. And if they match, that means the user supplied the right password, even though we don't store the plain text password anywhere in the database. And these functions, hash and compare, are not ones that I wrote. They are coming from this very popular Node library called bcrypt, which is written by people who are experts at encryption. So I can just trust that that's very likely to be implemented properly and use it directly here in my code. So the last step then is in the happy server, where we are, so this is the creation of an account, but when I log in, a little farther down here, the post to the login endpoint, the first thing I did was, again, fetched the account record that had an email that matched the email that came in this sign-in request. Then if that was non-null, in other words, it did find such an account, and account.verifyPassword returns a true value, right? So again, because if I go back here to my account class, I'm putting the verify password just as a method inside of this account class, right? These are ordinary JavaScript classes, and I can define my own methods as I see fit. And because this verification process is really part and parcel of what you do with accounts, I just added it as an instance method inside this class. So when I fetch the account out of the database with the account.query.get, that gave me an account object, and because this thing is defined on that account object, the this.password reference refers to the encrypted password for that account that I just brought in. Go back here to the server, and then you can see how the account I've pulled in from the database is being invoked here, or being used to invoke the verify password, and I'm passing in the plain text password that came in with the request. So if that passes, then I go ahead and log the user in. Notice that because verify password is itself is itself an asynchronous function, right? Because compare is an asynchronous function. So once we go down that path forever, it controls our destiny, right? well, we've got an asynchronous function inside of here. That means this guy's got to be asynchronous, which means that back here in the server, we need to wait for that thing to finish checking to see if this is in fact the right password, so that we can evaluate this conjunction here to say, yes, we found the account, and yes, it has the same password as the one that the user typed in from the user interface.